Good afternoon, everyone. Country Flyboy here, and today the 8th video in our ADE Edit and Airport series. I've recorded this one already, actually, and I've gone back, and I've actually recorded almost all of the videos in this series already, and I've gone back and looked at it, and I think, I need to re-record this one, so this is draft 2. And in this video, we're going to be editing the approaches. So, approaches are... It's well known that the nav data in Flight Sim X is basically locked to 2006. It's really, really hard to update the nav data. There are things that do it, but they have to decompile a metric fuck ton of BGL files, make the appropriate edits, then recompile them. That can be a bit dangerous. So, so a lot of people don't even really bother, but it's pretty much decided that you just can't update nav data in Flight Sim X. But really, you can. It's just hard to do. But there is one thing that's easy and anyone with Airport Design Editor can do, and that is approaches. Approaches are the easiest part of the navigation data to edit. They are ridiculously easy. So I'm going to switch us over to approach mode in a second. Before you start editing approaches, make sure your runways are both set up correctly and positioned correctly. Now, first thing I'm going to go is we're going to be editing this approach here, the ILS Localizer Runway 25. There are 3 approaches at this airport. This one, an RNAV for Runway 7, and an RNAV for 25. Now, I want to mention a common mistake I see from a lot of scenery designers, particularly in the payware crowd, makes this mistake quite a bit. I'm going to bring us up to Atlanta real quick. As soon as I find it, LaGrange, Charlotte, Birmingham should be right around here. So we're going to be going to Atlanta. Now, down here's the approaches. I see a common mistake, and it drives me crazy when people do this. I'm just going to load up the ILS runway 8 left approach. So the common mistake is people will include stars as part of the approaches, and no, stars and approaches are 2 separate things. Stars are an arrival. They're essentially, they're kind of special. They're sort of part of the en route environment, but they're also sort of not. So don't include them. I've seen, who was it? I think it was, go away, Susie. I think, Imagisim, they made Atlanta international scenery, and they did that. Their approaches, the transitions were the stars, and that drove me up a wall, because no, stars are 2 separate things, stars and approaches, so don't do that. This approach has 1, 2, 3. Final approach fix is Shield, and Bizarre is the initial, and you just got that. There are no stars to transition from this. Your transitions are Lari, Jaja, and Bizarre. That's the only transitions. There's no stars to join this. The stars end with vectors at this airport. So please don't do that. Anyway, on to the approaches. So we're going to load up approach mode. And since I've already recorded this video, I think, yeah, the approaches are still there. We're going to be deleting this one and redoing it because I actually messed up on it. So we'll go back to list. I am going to load up the RNAV for runway 7 and then delete this one. Don't delete an approach if you have it viewing in viewer, because bad things will happen. We're going to delete the ILS and we're going to redo that one from the ground up. So yeah, approaches can be edited. Now you may notice these blue lines have been drawn from the extended runway center lines. Those are not there by default. That's a thing I like to do to help me out when I am building approaches. So a lot of times when you update the approaches for an airport, you may find that either the approaches weren't there, they have been changed, or waypoint names have changed, or new waypoints have been added, yada yada yada. And if you look on this RNAV runway 7, we have waypoints. Now this approach is not default. This is an approach I had to build and add from scratch, which means I had to place all the waypoints, then build the approach. So the way you place these waypoints, I have not found a dependable source for the exact location of terminal waypoints like this. You can get them for en route waypoints, but terminal waypoints, they don't seem to give out. So what I often end up doing is just making them relative to each other. So I'm going to show you how I draw that extended center line. First, you use the guideline and draw it right along the edge of the runway like that. And try to get it perfectly straight. Put it right there on the edge. Make sure it is perfectly straight. You don't want it to vary any amount, any direction. Next, we're going to position it just in front of the runway numbers, right about where we want the approach end of the threshold to be. So if we look at this runway here, you see the threshold, the numbers. This forms the approach end of runway 25. We want the guideline to be just in front of that. So there's no threshold stripes, but runway 14's numbers serves as its approach end. So we'll put it just in front of there. Then we'll double click it and edit it. Now in approach mode, when you draw a guideline, you can draw it however long you want, but if you edit that guideline, it's going to make it be at least 2.5 nautical miles. So if you have to draw a guideline that's less than 2.5 nautical miles, make sure you get it right the first time around. So we're going to edit this to be 25 nautical miles. We're going to turn it blue, and we're going to make it 5 feet wide and get rid of the end bars. Okay. And as you can see, it has now drawn us a nice long 25 nautical mile long blue line right down the runway extended center line. This is done so that I know at all times where the runway center line is all the way out to 25 nautical miles. The reason I picked 25 nautical miles is if you look at the MSA circles on approaches, they're usually drawn to 25 nautical miles or 30 sometimes. Also on departures, you're guaranteed separation for 25 nautical miles around the airport. Alright, so that's why I use 25 nautical miles. That way I always know where the extended center line is, and I can place my waypoints relative to it. Then I just draw the waypoint, say if there was a new waypoint needed to be added 5 miles off the final for 1-4, I'll put a new guideline, make it 5 miles, go to where it ends, realize it's crossed. It wasn't exactly straight, but that's fine. I'll just line it up again, and we'll put a new waypoint there. Approach, not approach, we want to add terminal waypoint. WPA is fine, because we're going to delete that in a second. And just like that, we've added a new terminal waypoint. Now, what is a terminal waypoint? Terminal waypoints are waypoints that are associated with a given airport. These are probably the only type of navigation data that you can actually edit without any kind of problems. Terminal waypoints, since they're associated with a given airport, just like the approaches, you can change their names, you can move them around, you can add them and delete them. So that's actually really easy to do. See, if Hopis, I wanted it over here, just like that. Yeah, so pretty much, yeah, terminal waypoints you can add. Now, NDBs, even if they are terminal NDBs, this one's an en route, but terminal NDBs, you can't edit them. They are part of navigation stock data, so yeah, can't edit things like that. But terminal waypoints, these blue ones here, you can. Now, these magenta ones over here, these are part of the en route structure, and if you were to look at the en route charts, you'd see that they correspond. LOTS, if I go, I've already closed it. Anyway, LOTS is actually a intersection for two airways that pretty much come perpendicular to one another there. One comes from this VOR to LOTS and then over to Savannah. Victor 441, I think? I'm not sure. So yeah, we're going to be editing a new approach. Now, before you go around editing approaches, there's a bit of a disclaimer. You need to know how to fly them. Approaches are not well documented how to build them, and that's because it's assumed that you already have a certain amount of knowledge before you attempt it. So not only do you know how to need to know how to read these charts, you need to know how to fly the approaches as well, and that goes beyond just being able to read the chart. You need to be able to know what's expected of you, what the different leg types are, what the different approach phases are. Just a quick walkthrough. All approaches are built with certain phases to them, and certain minimums are given to you and certain things are expected of you during a given phase. So let's say we were arriving in this airport from the north. We would make our last en route waypoint the Dublin VOR, because that just makes sense. So here we have a feeder route from the Dublin VOR. This little arrow here indicates a feeder route goes to the Onion NDB. So we know this approach can get us from Dublin to Onion with no problems, and we won't hit anything. We're guaranteed to not hit anything if we are on that radial there. And we are given, that's the transition, or that's a transition. That's a particular type of transition called a feeder route, but it's a transition. The transition is the first phase of an approach, and that is simply to get you from the en route environment to an approach. And that's why I say stars are actually part of the en route environment. They don't get you to the approach. They get you to a point where an approach can be made via the transition. However, stars can also be a transition, so they're a little special. But yeah, so this is the transition, gets us from the en route environment to the approach, and we are given, I think, 1 mile and 1,000 feet separation from terrain and obstacles there on the transition, usually. So once we hit Onion, we are beginning the initial leg, which is the outbound leg. So we hit Onion, then we turn on the 069 localizer outbound or the 069 bearing outbound from the Onion NDB. You can use either one, but that's the initial leg. You're still given, I think it drops on the 1 mile part and just gives you 1,000 feet separation from terrain and obstacles at that point. Just not a lot, but it's plenty. So, yeah. We complete the procedure turn. We got the procedure turn bar up here. And then at the completion of the procedure turn, once we are tracking inbound again, we are on the intermediate leg. The intermediate leg gives you 500 feet separation from terrain and obstacles. It's vitally important that you are on course when you are on the intermediate leg. Very, very important. And you're at the altitude. Once we complete the initial at the end of the course reversal, we can drop down to 2,000 here, as indicated by the chart. Then we track inbound to the Onion NDB. Once we cross the Onion NDB, we are at the final approach fix, and we begin the final segment of the approach. And final segment will guarantee you 250 feet separation from terrain and obstacles. So if you think that 500 feet on the intermediate leg is small, 250 feet is dangerously close. So definitely need to be on course there. You better not be off by more than a mile when you're on the final leg. And you better be on altitude, because you're only given 250 feet separation. It's a little different with localizer and ILS approaches, I think. But anyway, that'll take us all the way down to the decision height, because the decision height is the missed approach point on precision approaches like this. And, yep. Then the missed approach just gives you terrain and obstacle separation. I don't think there's any particular separation minimums for the missed approach. It just guarantees you won't hit anything. So yeah, that's the basics of an approach. You need to know how to fly these well before you start building them. So although it's really simple, we're going to start the ILS approach. So we're going to build the ILS localizer runway 25. By the way, ILS and localizers are two approaches on one chart, by the way. So just so you know. So we're going to set runway 25. This is the ILS. We don't need an approach suffix. You could type in, say, a Yankee or a Zulu there if there was more than one ILS approach for that runway. Or you could assign this to runway 00 and just put A, and that would make it an ILS alpha approach, which means it doesn't go to any runway. It just drops you off at the airport and you have to circle to land. So these two things here, fixed type, fixed ident, IAF type, IAF ident. What is this? This is asking you what the final approach fix is and what the initial approach fix is. Now this is pretty easy for this approach, because both the Onion NDB is both our final and our initial approach fix. So the Onion NDB it's not a terminal NDB. I thought it was at first, but it's not. It's actually an en route NDB, UQN, and we're going to set it as both. It's our initial and our final. Actually, I'm going to set I have to take a bit of creative license here, because when we're building the approach, we're building initially the vectors to final approach. So vectors to final, that is a type of transition where ATC just gives you radar vectors to final. They don't take you on any particular track. Now that is done by default. All approaches will have a vectors to final transition by design. So we need to set this up. Now, the way vectors to final works is they vector you to intercept the final approach leg just before the final approach fix. So if we were to look at the chart, UQN here is the final approach fix. If you're getting vectors to final, ATC is going to vector you to join the localizer somewhere between the Onion NDB and the Sevefk intersection right here. They're going to have you join that course right there. So we need to do a little creative license when we're building this approach. We're actually going to make the initial approach fix Sevefk and just click add. Now, it hasn't done anything except get rid of the one we already had. And it's added our first waypoint leg. We'll talk about them in a second. So we have details for the approach right here. You can change these, by the way. You can change the approach type and all that from here. So if you messed up, don't worry. You can always just come back here and change it. Runway designation. If there was a left and right center version of the runway, you could change it here. We can just click none because there is only one runway. Suffix, we don't need. GPS overlay. I don't really know what that does. I usually leave it unchecked, and it works just fine. So I'm not 100% sure what that does. Anywho, fixed type, we already covered all this. The thing we need to look at here is the approach altitude and the missed approach altitude. Missed altitude in feet. So if we look at the plate, the approach altitude, the altitude at which we cross the initial approach fix, 2,000. Right there. It says it right there. It also has it pretty much on both transition legs. So we're going to set the approach altitude as 2,000. The missed approach altitude is what altitude do you climb up on the missed approach. In the case of this, we've read the missed approach section, climb to 1100, 10 turn left, 2,000, direct UQN, NDB, and hold. So 2,000, again, is the altitude for the missed approach. Now, this thing here that it added, approach leg IF, this is usually what confuses everybody. You see when I selected that, it drew a circle. That indicates IF just means initial fix. So that's the initial fix that ATC is going to reference when they are clearing you for the approach, basically. So we have other altitude settings here, or other settings here. We don't really need to touch any of them except for the altitude. We need to have the altitude discretion can be a plus, minus, A, B, C, G, H, I, J, V in space. I don't know what any of these do. All I know is A is at, plus is at or above, and minus is at or below. Those are the three you're going to need most of the time on approaches. And 9 times out of 10, you just need to use plus, because if you look at the line here, 2,000 is an at or above altitude. So we need to be at 2,000. Now you also have another altitude window here, altitude 2 in feet. Now I realize I typed a 1 there instead of a 2. I don't know what this is. I guess it's just an alternate altitude they can take you to. I'm going to use 1,500 because you drop the 1,500 on this leg to intercept the glide slope. So that's what I'm going to use. I don't really know what that does, but it's there. I usually just... There's an intelligent way I pick the altitude. Now we need... So we have this thing set up. IF basically means you need to get to this waypoint somehow. So we're at this waypoint. Where do we go from here? We go to the NDB, then we join the localizer inbound. Alright, so we need to add a new approach leg. This is where everyone gets confused because the hell does all this mean? And I'm going to have a document down in the description for you. If I can't find a link to it, I'll just put it on my Dropbox. This is the leg types document. Can't remember who made this. Thank you for doing it. This will list the leg types that you can use. Actually, these are all the leg types for all instrument approaches. And all of them, with the exception of one, is modeled in Flight Sim. The only one that's not modeled in Flight Sim is the RF leg, which is the newest type of approach leg, was added a few years ago. after the 2006 data compile for Flight Sim X. The RF leg is radius to fix. You basically draw an arc, and you fly an arc between two waypoints instead of a straight line. That is not to be confused with the arc to fix up here. I think it's up here. No, it's right there. Arc to fix, which is the DME arc, where you need some type of DME to guide you on the arc. This one is completely RNAV, so you don't need any extra equipment other than your RNAV equipment to fly the RF leg. All right, now, I don't know of any airplanes, with the exception of one off the top of my head, that are available for Flight Simulator that can actually fly RF legs. And the only one I know of for sure is the iFly 737NG. I think the PMDG can do it now. I know it couldn't when it first came out, but I think the PMDG NGX can actually fly RF legs now. Don't quote me on that. I know it couldn't when it first came out, and the iFly could. So, and really, since this is not replicable in Flight Sim by default, you're going to need Navigraph or Navdata Pro or some other navigation data type that uses its own nav data instead of the built-in Flight Sim X one. So real quick, let's go over the type of legs we have. The one you're going to be using the most often is TF, or track to fix. It's simply go from A to B. Next we have PI, or procedure turn to intercept. Initial fix, IF. Course to altitude, or CA, where you fly a particular course until you get to an altitude, then the next leg starts. Then you have three types of holding patterns. You have hold to fix, hold to altitude, and hold to manual termination. Hold to fix is what you use in lieu of a procedure turn. Hold to altitude is what you use when you need an airplane to climb or descend inside of a holding pattern. And hold to manual termination is how you end most missed approaches. Not all missed approaches end with a holding pattern, but most of them do. And hold to manual termination simply means you hold till you decide not to hold anymore. Course to intercept, or CI, means you fly a particular course until you intercept the next course. Direct to fix, or DF, means you go from your present position direct to the next waypoint. Course to DME termination means you fly a course till you're a particular distance from a VOR. Fix to altitude is fly a certain course outbound from a particular fix till you hit a certain altitude. Course to radial interception is you fly a course to or from a particular waypoint till you hit a radial from a VOR or an NDB. That's CR. Course to fix, mostly used on ILS and localizer approaches like this one, and that is you fly a particular course to the next fix. Right. Fix to distance on course is you fly outbound from a particular waypoint on a certain course till you hit a certain distance from that course, not to be confused with course to DME termination. Then down we have fix to DME termination, which is pretty much the same as fix to distance on course. You fly a course outbound from a fix until you hit a certain DME. In this case, though, it's going to be DME that's not from the original waypoint. So from a separate waypoint or VOR. We have heading to next leg intercept, manual or fix to manual termination, which is how some instrument approaches, missed approach procedures end. At a waypoint, you fly a particular heading. Most stars end with one of those. We have heading to a radial termination, where you fly a heading until you cross a particular radial. We have arc to fix, which is the DME arc. We have heading to DME distance, fly a heading until you hit a DME. Heading to altitude, where you fly a heading until you hit an altitude. And heading to manual termination, just fly a heading until you decide not to anymore. Now, certain assumptions are made both in ADE and by the default GPS. These assumptions are used to draw the particular arcs and hold marks and everything. And that is a ground speed of 210 knots, and that's computed based on 3.5 nautical miles per minute. A course reversal max of 4.3 nautical miles used turn inbound, or before the turn inbound, if no distance is specified. A max 25-degree bank angle to compute turn radius, a max climb and descent rate of 500 feet per nautical mile, and intercept angles, if not specified, no more than 30 degrees for a localizer and 30 to 45 degrees for all others. So that is the leg types. That's a very useful document to have. So from Cvep, we just got to get to onion. Now we can do that pretty simply with a track to fix to the onion NDB. Just like that. And as you can see, it's drawn a nice line for us. Right along, or slightly off the extended center line, but pretty much right along it. Now, we select that leg, and it's highlighted it. It ends at the arrow. We need to enter some details about this leg. We can pretty much leave everything as is, except for the altitude. You have to have an altitude on each leg of an approach, or it's not going to work. It'll have a fit when you try to compile it. So the altitude discretion is plus or at or above, and we need to be at 1,500 feet when we hit the onion NDB. So we're just going to quickly put that in, 1500. Now from the onion NDB, we join the localizer to the runway. So how we do this is we add the approach leg. Now we're tracking a localizer on this leg, so we got to use the course to fix leg type. You could also use track to fix, because you're going to be going pretty much along the center line here. If you want, it's not technically you should use course to fix, but you can use track to fix, because if you're flying this approach, you're going to be referencing your radio navigations, not the GPS. So you'll be using the localizer beam signal here, not your GPS RNAV capability. So it's entirely okay to use a track to fix leg here, especially since we have these waypoints aligned pretty much exactly on the runway center line. However, if the final approach fix is not on the extended center line, or the localizer is not aligned with the runway, say it's a ILS-A approach, then you need to use track or course to fix. I'm going to use course to fix to the runway, and you see it gets rid of everything there. Because from here, there's no other waypoints in between, we just go straight to the runway. Now, course to fix, we do have some extra information to enter. So to the runway, runway 25, course type is magnetic. We need to enter the course heading, which is 249. 249, I need to turn, oh my god, I can barely see my keyboard. 249. The distance on that course, or this in this case is the distance from the final approach fix to the runway, 3.7 nautical miles. I don't think you have to enter that. I think the GPS is perfectly capable of doing it by itself. Turn direction. So we have turn directions, and most of the time you don't need to bother with this, but for the final approach leg and the first part of the missed approach leg, as well as with procedure turns and holding patterns, you do need to bother with this. So your options are L, R, and E, or left turn, right turn, or either. In this case, we'll go with either since it's the final approach leg. Rec type. Now, I don't know what rec means, but this seems to be what are you referencing for the course. In this case, it's the localizer. Rec region. Now, this it doesn't autofill this in. You need to know this yourself. We'll turn caps lock on. We're in region K7, which is the 7th region of the K area, or the US. Rec ident, we can get from here, and that is IVDI, India, Victor, Delta, India, India, Victor, Delta, India. Theta degrees, which is the course that you're tracking inbound, the course for that you're trying to track, again, 249, and Rio nautical miles, 3.7. We can just use the same numbers. Altitude discretion. Now, this is the final approach leg. It ends at the runway. So here, we need to set the altitude discretion to at. Not plus or minus, but at. Now, for this leg, I tend to use the minimums as the altitude discretion, or the altitude, and we got 3 different minimums here. We got straight in ILS, straight in localizer, and circling, as well as different category minimums. I tend to use the lowest minimums on the type of approach it's going to use. So ignoring the categories, which one's the lowest? Normally it's going to be the alpha type cat. And which one is the approach that's going to be flown the most often? This is 2 approaches in one. So most often it's going to be the ILS approach. You only fly the localizer if you want to, or if the glide slope is out of service. So the ILS minimums for here, since ILS is the most common type, is 473 feet. So we're going to punch that in, 473 feet. Altitude 2, I'm just going to use the same number. And just like that, that is the approach done.